Welcome to the next session of Subject Engineering Maths, Chapter 4, Complex Variables. Now let us start the session with classroom workbook. Just go through classroom workbook. Let us start the session with question number 5. The real part of six into e power I pi by 3 is blank. So we need to find real part of 6 times e power I pi by 3. Now actually this is 6 into e power I pi by 3. So this is 6 into e power I theta. So I am applying cos theta plus I sin theta. So cos pi by 3 plus I sin pi by 3. Theta value is pi by 3. Now this is, what is the real part of this? So therefore real part is 6 times cos pi by 3. So therefore this is 6 times cos 60 degrees. Cos 60 degrees is 1 by 2. Therefore the value is 3. Just we have applied the formula e power I theta is cos theta plus I sin theta. Now here theta is pi by 3. So its real part is 6 times cos pi by 3. But cos 60 degrees is 1 by 2. Therefore the real part of this complex number is 3. The value of 1 plus I whole power 8. So we need to find this value 1 plus I whole power 8. Options are given. So in options, 2 values are real numbers, 2 values are complex numbers. Let us see. Now this expression we can write it as 1 plus I whole square whole power 4. 2 times 4 is 8. Now apply a plus b whole square. This is a square plus b square plus 2ab whole power. This is 4. But what is I square value? Minus 1. I square is minus 1. So 1 minus 1 plus 2i whole power 4. 1 and minus 1 will gets cancelled. This is 2i whole power 4. So this is 16 into I power 4. Here I square value is minus 1. Therefore, I power 4 is 1. So, I power 4 is 1. Therefore, the answer is 16. Therefore, option C is right answer. Question number 7. The modulus of the complex number 1 plus I divided by square root of 2. 1 plus I divided by square root of 2. So, assume that this is my Z. So, Z equal to 1 by square root of 2 plus 1 by square root of I. This is in the form a plus ib. So what is the modulus of this? Square root of a square plus b square. Here a value 1 by root 2, b value 1 by root 2. When you square them, you will get square root of 1 by 2 plus 1 by 2. This gives answer as 1. So option C is right answer. It's a very straightforward question. Just apply the formula. You get 1 as answer. For a complex number z equal to 1 by 2 plus root 3 by 2 I, comma, the value of z power 6 is. This is the complex number. They ask us to find z power 6. As I mentioned in the last session, if you want to find powers of a complex number, use the formula e power I theta equal to cos theta plus I sin theta, right? So therefore, let us apply the same technique here also. So this z we can write it as like this. This is actually 1 by 2. So we can write it as cos 60 plus this is I, this is sin 60. So therefore this z we can write it as cos pi by 3 plus I sin pi by 3. So this is e power I pi by 3. Therefore z power 6 is e power I pi by 3 whole power 6. Therefore this is e power I 2 pi. Now again it is in the form e power I theta. So therefore this is cos 2 pi plus I sin 2 pi. Anyhow sin 2 pi is 0 but cos 2 pi is 1. Therefore the value of z power 6 is 1. Just we expressed 1 by 2 plus root 3 by 2 I like this. Cos pi by 3 plus I sin pi by 3. Now it is equivalent to e power I pi by 3. So z power 6 is e power I pi by 3 whole power 6. So it gives e power I 2 pi. Again, it is in the form cos 2 pi plus I sin 2 pi. Simplify this, you will get 1. Cos 360 is 1 and sin 360 is 0. So the answer is 1. That means B is right answer. The function f of z equal to z square plus 1 by z square plus 4 is singular at. So that means we need to find the singular points of this function. What do you mean by singular points? A point at which function is not differentiable is called a singular point, right? Now in the denominator we have z square plus 4. So make the denominator equal to 0 and solve for roots. They become singular points of whole expression. Okay. So therefore make this denominator expression equal to 0. Z square plus 4 equal to 0. So this implies z equal to plus or minus 2i. So therefore the singular points of this function are plus or minus 2i. So option D is right answer. Next question number 10. The value of 1 power I is blank. Very interesting question. Generally anything power 1 is 1 provided that the power value is finite value. But here I is a complex value. So generally when you discuss real numbers we can discuss finite values. But here I is a complex value. Now let us see. This one we can write it as 1 power 0. Simple. Whole power I. Now a power m whole power n. So this is a power mn. 0 into I is 0. So this is simply 1. So therefore 1 power I is equal to 1. 1 power I is equal to 1. Now let us move to question number 11. If z is a complex variable, then integral phi to 3i dz by z is integral phi to 3i dz by z. Now let us go for complex integration. This is integral phi to 3i 1 by z dz. Integral 1 by z is log z, normal integration. Integral 1 by z is log z. Of course here the base value is e. When I don't specify base, by default it is e. So integral 1 by z dz is log z to the base e. The limits are phi to 3i. So apply upper limits. So they are log 3i to the base e minus log 5 to the base e. Now here it is in the form log ab. The difficulty comes at this moment, log 3i to the base e. Now here dot is there, log of ab. So log a plus log b, we can write it as log 3 to the base e plus log I to the base e minus log 5 to the base e. Now group this and this. This is log a minus log b. So we can write it as log a by b. So log 3 by 5 to the base e plus log I to the base e. Therefore this expression is 3 by 5 is 0.6. So log 0.6 to the base e plus log I to the base e. Now how to get this? How to get this log I to the base e? We know that the value of I is e power I pi by 2. The value of I is e power I pi by 2. Therefore at this moment you can replace I by e power I pi by 2. So this is log 0.6 to the base e plus log of this I, we can write it as e power I pi by 2 to the base e. Now this I pi by 2 comes before this log value. So this is log 0.6 to the base e plus I pi by 2. Log e to the base e is 1. Now when you look at this log 0.6 to the base e, just go through logarithms. The value is minus 0.511. Log 0.6 to the base e is minus 0.511 plus I into pi is 3.14. Here the value of pi is 3.14. So 3.14 divided by 2. This is 1.57. Therefore, the result is minus 0.511 plus I into 1.157. So option B is right answer. Only thing is, the trick in this question is you must replace this I by e power I by 2. Otherwise, it is very simple. Okay. So note this calculation. Well, given two complex numbers, Z1 equal to 5 plus 5 root 3 I, comma Z2 equal to 2 by root 3 plus 2I. Two complex numbers are given. Then the argument of Z1 by Z2 in degrees. So we need to find argument of Z1 by Z2 in degrees. Options are given. Now let us see, we have a formula for argument of Z1 by Z2. So this is given by argument of Z1 minus argument of Z2. So therefore this argument is a tan inverse. This is B value and this is A value for complex number Z1. So tan inverse of B by A, 5 root 3 by 5, it is root 3 minus tan inverse of, and this is B value and this is A value for second complex number. Tan inverse of B by A, 2 by root 3, so this becomes root 3. Tan inverse root 3 minus tan inverse root 3, this is 0. Therefore, its argument is given by 0 degrees. So option A is right answer. Let f of z equal to az plus b divided by cz plus d. If f of z1 equal to f of z2, for all z1 not equal to z2. So this is az plus b divided by cz plus d. It seems to be bilinear transformation, but don't confirm that this is a bilinear transformation. This becomes a bilinear transformation only when AD minus BC is not equal to 0. So this is my f of z. F of z equal to f of z1 equal to f of z2 for all z1 not equal to z2. Now the values of ABC are given. A value is 2, B value 4 and C value is 5. Now in that case, what is D value? So one value is missing, we need to find that value. Now let us see how to get this. Here one simple way is, here f of z equal to az plus b by cz plus d, and this information is given. So f of z1 is not equal to f of z2 for all z1 not equal to z2. So you can take z1 equal to, for example, 1, z2 equal to 0. Because it is true for all z1 not equal to z2. You can take any two values of z1 and z2, but they are different numbers. So I started with z1 1, z2 0. I get the answer very easily. Therefore, what is this f of z1? This is basically az1 plus b divided by this f of z1, cz1 plus d, equal to this is az2 plus b divided by cz2 plus d. This is f of z1 and this is f of z2. But z1 is 1 and a value is 2. So this is 2 plus b value is 4. 2 plus 4 divided by z1 value is 1, c value 5. So 5 plus d equal to, here anyhow z2 is 0. So b value 4 and d you need to find out this. Therefore in this case, this expression becomes 2 plus 4, 6. So 6 divided by 5 plus d equal to, this is 4 by d. So this implies 6d equal to 5d plus, this is 6 by 5 plus d equal to 4 by d. So this is 5 into 4, 20 plus 4d. So therefore this implies 2d equal to 20. Therefore the value of d is 10. So therefore the value of d is 10. You can take simple like this. Or equivalent way is, you can do like this. Another equivalent way you can do like this. Here f of z1 equal to f of z2. So therefore, what is A value? 2. So I can take 2z1 plus 4 divided by C value is 5. 5z1 plus D equal to, this is 2z2 plus 4 divided by 5z2 plus D. Cross multiply this. So this into this, 2 times 5, 10. 10 z1 z2 plus this is 2d z1 plus 20 z2 plus 4d is equal to, this cross multiply this, 10 z1 z2 plus 4 z1, sorry, this is 20 z1 plus 2d z2 plus 4d. Now 10 z1 z2, 10 z1 z2 will be cancelled, 4d will be cancelled. Now what is left on LHS and RHS? This is 2d z1 plus 20 z2 equal to 20 z1 plus 2d z2. Now rearrange these terms, you will get 2d into z1 minus z2 equal to 20 times z1 minus z2. Now here this expression is true for all z1 not equal to z2. When z1 is not equal to z2, this is a non-zero expression. Since this is a non-zero expression, you can cancel out this. Therefore, in this case, 2d equal to 20, therefore d equal to 10. See, in this question, they mentioned very clearly f of z1 equal to f of z2 for all z1 not equal to z2. So, when z1 equal to z2, you cannot cancel z1 minus z2 on both sides. Because when z1 equal to z2, this will be 0 and this will be 0, you can't cancel. Therefore, since the result is true for all z1 not equal to z2, so this is a non-zero expression. This is a non-zero expression. When a non-zero quantity repeats on both sides, if multiplication operation is involved, you can cancel on both sides. So therefore, in that case, 2d becomes 20, d value is 10. So this is simplest way and this is another way. Write both the ways. The fixed points of f of z equal to 2iz plus 5 divided by z minus 2i. So the fixed points of this function or options are given. Suppose z is a fixed point. Assume that z is a fixed point. So when z is a fixed point, what does it mean? F of z equal to z. So take this equation, find its roots, you will get the fixed points. Therefore, this is 2iz plus 5 divided by z minus 2i equal to z. This implies 2iz plus 5 equal to z square minus 2iz. This implies z square minus 4iz minus 5 equal to 0. Now this is a quadratic equation which is in the form az square plus bz plus c equal to 0. Here a value is 1 and b value is minus 4i, c value is minus 5. It is in the form az square plus bz plus c equal to 0, quadratic equation. We know how to find the roots of a quadratic equation. Here a value 1, b minus 4i, c value minus 5. So the roots are like this. Z equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So therefore, here b is minus 4i. So this is 4i plus or minus 4i whole square with the square root minus 4 into a value 1 and c value is minus 5 divided by 2a. So a value is 1, this is 2. So this is 4i plus or minus, this is 4i square. So this is minus 20, 16. So this is 16 plus 20. This is minus 16 plus 20 divided by 2. So therefore this is 4i plus or minus square root of 4 divided by 2. So this is 4i plus or minus 2 divided by 2. Therefore the z values are 2i plus or minus 1. So these are my fixed points. One is 2i plus 1, second is 2i minus 1. Be cautious about option B. In option B we have 1 plus or minus 2i. But this is wrong option. When you take plus, 2i plus 1 is same as 1 plus 2i. But when you consider minus, this is 2i minus 1 and that is 1 minus 2i. So option B is wrong. Anyhow, directly we have is option C. So C is right answer. So how we got this? Just by taking the definition. If I assume that Z is a fixed point, then I will get f of Z equal to Z. Then it becomes a second degree equation. Apply the roots formula. You will get Z value 2i plus or minus 1. Okay. So note these points. So what it is? If a complex number Z equal to root 3 by 2 plus I into 1 by 2, then Z power 4 is. So my complex number is this, root 3 by 2 plus I into 1 by 2. We need to find Z power 4. As usual, when you need to find powers of a complex variable, then apply the formula e power I theta equal to cos theta plus I sin theta, right? So therefore here this Z is nothing but this root 3 by 2, I can write it as cos 30 degrees. So cos pi by 6 plus I into this is 1 by 2 is sin 30 degrees, that is pi by 6. Therefore Z equal to e power I pi by 6. So Z power 4 is e power I pi by 6 whole power 4. So this is e power I 2 pi by 3. Therefore, this is cos 2 pi by 3 plus I sin 2 pi by 3. Now, this is cos 120. Cos 120 is minus 1 by 2 plus sin 120 is root 3 by 2. So, the result is minus 1 by 2 plus I root 3 divided by 2. So, option B is right answer. To question number 16. The complex number Z equal to x plus jy. Here I and j both the meanings are same. I square equal to minus 1 or j square equal to minus 1. That satisfy the equation mod z plus 1 equal to 1. Lie on different options are given. A circle with 1 comma 0 as the center, radius 1. Circle with minus 1 0 as the center and radius 1. Y-axis, x-axis. Let us simplify this. This is in the form modulus of z minus 1 equal to 1. It is in the form modulus of z minus a equal to r. So what is the center? Center is a comma 0. What is the radius? Radius is smaller. So it represents a circle having center at a comma 0. Here a value is minus 1. So center of this circle is minus 1 0 and radius is given by 1. Therefore, these lie on the point a circle having center at minus 1 comma 0 and radius 1. Therefore, option B is right answer. Question number 17. An analytic function of a complex variable z equal to x plus iy is given as f of x comma y equal to u of x comma y plus I into v of x comma y. So what is z? Z is a complex variable. An analytic function of this complex variable is given by like this. F of x comma y is u of x comma y plus I into v of x comma y. What is u of x comma y? This is 2k times xy. And what is v of x comma y? X square minus y square. The value of k for which the function is analytic. So what is the value of k for which this function is analytic? If a function is analytic, implies it is differentiable. Implies CR equations must hold. CR equations must hold. So I can use any one of the CR equation. Let us use first CR equation. Ux must be equal to Vy. What is Ux? Dou u by dou x. Vy means dou v by dou y. This implies dou u by dou x is 2ky. Dou v by dou y is minus 2y. Therefore, the value of k is minus 1. Simple point, analytic implies differentiable. When a function is differentiable, automatically CR equations must be satisfied. So there are two types of CR equations. One is ux equal to vy, another one is ui equal to minus vx. I used the first CR equation. I got directly k value minus 1. Okay, note these points.